In this video, we are going to review the key pieces of information that we need to know to be able to graph a polynomial function. And we're going to do this using the factored form of this equation. There are 5 things that we want to be able to identify before we can graph. So the first thing that we're going to find is the leading coefficient. The leading coefficient is the value, the number that's before a variable, and the leading coefficient comes when we multiply all of those together. So in this case, I'm thinking about the coefficient of this variable and this variable, and because there isn't anything written, I know it is actually 1. So I have a coefficient of 1 times 1, and then I want to pay very close attention and realize that it is negative. So my leading coefficient here is -1. My degree is coming from looking at the exponent for each of the factors. And in this case, because I don't have a factor written here, I can count it as 1. So when we're finding the degree, we're finding what those exponents equal, and in this case, it would be to the 3rd degree. So our degree here is 3. Our zeros come from being able to take each term and making them equal to 0, and then solving for x. In this case, I have x equals -8, and here when I subtract 1 from both sides, I get x equals -1. So my zeros are at -8 and -1. Our constant comes from finding or multiplying the constants for each of the factors. And here, we want to remember that this 8 is actually happening 2 times. So the constant would be 8 twice with the 1 from here. We also want to remember that it is negative, so our answer is going to be -64. And the last bit that is important to know is about multiplicity. Multiplicity tells us how a graph reacts at the degree for each of those factors. So in this case, we have at the 0 of -8, we have a multiplicity of 2. And at the 0 of -1, we have a multiplicity of 1. And as we graph this, we'll see how that influences our graph. So the nice thing about sketching a polynomial function is it's just a rough draft. As long as I get all of these correct, my graph will be correct. So I'm going to start by marking where my zeros and my constant are. So I have a 0 at -8, -8, and at -1. I also have a constant at -64. I don't have to go through and make all of the tick marks here. It's just more important to know that the constant is here on the negative y-axis rather than up here on the positive, because then I'll know another point where my graph can go. Now I want to start to think about the end behavior of this graph. And the end behavior comes from the leading coefficient and the degree together. So for the leading coefficient, I know that it is -1. And when the leading coefficient is negative, it tells me that my graph is going to end in the negative direction. So as x is increasing, y is decreasing. So I know it is going to come end down here somewhere, And now I have to think about what's happening on this side of the graph. I can figure that out by looking at the degree. The degree tells me, because it is odd, it tells me that the end behavior of the graph is going to go in different directions. So an even would go in the same direction, but an odd is going to go in different directions. So my graph is going to look like this because it is both negative and odd. So when I'm sketching the graph, what I like to do is put little arrows to show that it's going to go negative and it's going to go odd. I'm putting an arrow here because this graph will go negative this way, and because it's odd, it's going to go in opposite directions. So now I just need to think about my multiplicity and connecting everything. So here I have a multiplicity at -8. That means, and that multiplicity is 2, which is odd. And whenever it has a multiplicity of 2 is even. Whenever it has an even multiplicity, it is going to bounce. It's going to bounce and look kind of like a quadratic. So I know that my end behavior is coming from here. Let me actually move that over a little bit. My end behavior is coming from this direction. It's going to go to 8 and bounce, or -8 and bounce, because that is where the multiplicity is 2. It's going to turn directions because it needs to go through this -1. It's going to go down to this negative constant and end in this negative direction. And that's it. Let's see a second example. Go ahead and try and pause and see if you can find all of these vocab words from this function. So my leading coefficient is going to come from multiplying the coefficients of each of our variables and our factors. And here I am getting 2, and it is positive. My degree comes from adding all of the exponents for the factors. So 2 plus 1 plus 1, because if it's not there, it's an invisible 1. Just 4, and 4 is even. My zeros come from making these all equal to 0 and solving. So I have -6, -1, and in this one, it is not +5 because x is not, there's not just one x, there's 2 of them. So when I get +5 over here, I want to make sure I divide by 2, and I'll get x equals 2.5. So I have -6, -1, and +2.5. The constant comes from multiplying the constants of each of the factors. So I would have 6 2 times because it has an exponent of 2. So 6 times 6 times -5 times +1. And I believe this gives us like 1, so it's 36 times 5. This is going to give us 180. And let's check our sign. A positive times a positive is positive. Positive times negative is negative. And a negative times positive is negative, so it will be -180. We're going to look at multiplicity. So remember, multiplicity is about our exponents at each of the zeros. So at -6, I have a multiplicity of 2, which means it will bounce there. At 2.5, I have a multiplicity of 1. So it will not bounce, it will go through the line. And the same thing will happen at -1. So let me clean this up a little bit. And now let's sketch. I have zeros. I'm going to do those first. I have a 0 at -6 and -1 and +2.5. I have a constant at -180, so I can just put that there. My leading coefficient is 2, which is positive, which tells me that my end behavior is going to go up, like that. So I'm going to draw a little arrow here to show that's going up. And then my degree is even, which tells me it goes in the same direction. So this is what my graph will look like. So I'll draw another little arrow here to show this end behavior going up. Now I'm going to look at the multiplicity. At -6, I have a multiplicity of 2, which tells me at this point right here, I need a bounce. It's either going to bounce this way or it's going to bounce this way. It's going to bounce this way because it needs to connect with that arrow to show me that the end behavior here is going up. So it will come down, it will bounce. I see my next point, so I'm going to curve around to it. I see my next point is down on the constant. I'm going to curve back up to this and end in my positive direction.